Assalamualaikum everyone, welcome to our presentation. From the picture, I am on the left side, Muhammad Fadli as a speaker 1, and on the right side, Khairul Kabir, my friend, as a speaker 2. Today in this video, we're going to present the concept of time division multiple access, abbreviated as TDMA. So without further any delay, I'm going to present you TDMA. From this presentation, we divide our task into two. I'm as speaker 1, will cover for the introduction, then understanding TDMA structure, and the last one, I will cover for time division multiple access. As a speaker 2, Kabir, he will cover for features of TDMA, efficiency of TDMA, and the last topic is numbers of channel in TDMA system. There will be a simple calculation will be touched under topic of efficiency of TDMA and number of channel in TDMA system. Introduction of TDMA. By definition, TDMA is a multiple access technique used in communication system to allow multiple users to share the same frequency band by dividing time into discrete slot or frame. In order to understand this concept further, here I prepare graphical representation of TDMA. I believe you must be familiar with FDMA. FDMA is slightly different compared to TDMA. In FDMA, every user will have different frequency, but in TDMA, every user will be using the same frequency, but they will have different time slot for every user. If you can see that we have user 1, user 2, and user 3. User 1 will have the time slot for user 1, and then user 2 will have his own time slot, and user 3 will have his own time slot. On the right side, I also prepare formal representation of TDMA concept. If you can see, on the x-axis is a frequency, on the y-axis is code, and the z-axis is for time. We have channel 1, channel 2, and channel 3. Channel 1, channel 2, and channel 3 is representative for example, user 1, user 2, and user 3. You can see that for all three users, they use the same frequency on the x-axis, but they have different time slot for every user. And then we move to the user 1. In allocated time slot for the user 1, it will have a frame that consists of information generated by the user 1. This frame is a cyclic process. Once the particular user 1 time is exceeded, this frame will be passed to the second user. Once the time frame for the user 2 is complete, then it will pass to the third user. In the next slide, I will present in details what the information included in the time frame. We have preamble, information message, and trail bits. I will explain it further in slide after this. The first thing we need to understand in TDMA is TDMA divide entire radio spectrum into time slot, and each slot only one user is allowed either to transmit or receive. That is the first thing we need to understand on the TDMA. And then each user occupies a cyclically repeating time slot, which means that, for example, we have 10 users in TDMA. So the first user will be using entire channel bandwidth for example, for 5 seconds. After 5 seconds, the chance will be given to the second user. Then this process will be going on and until it reaches up to 10 user. Then the process will be repeating again to the first user, and then it goes to the second user, and this process is cyclically repeating. And then TDMA system transmit data in buffer and burst method. This make the transmission a discontinuous one. Okay. Example, if the time period is over for the first user, then the chance goes to the second user. The first user should wait his chance either to transmit or receive. While waiting the process to complete, user 1 that is in mode of waiting will be generating information, and all the generated information will be stored on the buffer. So once he got the chance, he will then transmit or receive the information. This process of sending and receiving, we call it buffer and burst method. This buffer and burst method is a discontinuous method, meaning in TDMA system, particular user cannot transmit on continuous phase. This means the user is only given a chance to transmit and receive information when his chance is given in his time slot. Hence, this makes the TDMA system more suitable for digital system. For the concept of duplexing, TDMA is divided by two concepts. First, TDMA TDD. In TDMA TDD, the single frame will be used as forward link for half of the duration and as a reverse link on another half. For FDD, two different frames will be used for the forward and reverse link, but the carrier frequency will be different. Okay, now let we try to understand TDMA frame structure. In this particular picture, we use three users, user 1, user 2, and user 3. And each user will generate message. For example, green is for the user 1, red for user 2, and purple is for the user 3. On the first slot for time, it will be given for the user 1. Once the time expired, the second slot will be given to the second user. And then the third slot for the time will be given to the user 3. And this process will be continue on the second frame. The time for the first slot will be given for the user 1, and then time for the second user, and then time 3 will be given to the user 3. This process will continue on the third frame. The slot 1 will be given for the user 1, slot 2 will be given to the user 2, and slot 3 will be given to the user 3. So this is how the frame will be transmitted in this TDMA system. Time division multiple access. Here we will see on how TDMA frame format can be visualized. Here, in one TDMA, it can be divided into three categories: preambles, information message, and trail bit. In the information message is contained for how many slots, and each slot will have trail bit, sync bit, information data, and guard bit. All this information is generated by one single user on his particular time. And preamble is consists of address and synchronization bits, which is used by base station subscriber to identify each other. And information message, it contain of multiple slot of user information, and each slot will have trail bit, since bit, information, and guard bit. So this is the concept of TDMA frame structure.
About features of TDMA. The various features of TDMA are single carrier frequencies shared among several users. That is one feature. So we don't want to get different frequencies which will actually eliminate the type of filters requirement as required in FDMA system. The handoff process is also much more simpler because we have sufficient time to switch over between one-way situation to another way situation, and there will be quite ideal time slot between one process than the other process. The transmission rules could be very higher in case of TDMA compared to the FDMA, because in FDMA the entire element bandwidth is allocated evenly for users. Each and every user will get a narrow band not exceeding to 30 kilohertz. Even though the user to communicate at any higher data rates, it is not possible because each and every user is limited with the frequency allocated to it. And that is not the case in TDMA. Each and every user in TDMA system is free to use the entire bandwidth over here. So this is actually the reason for getting the high transmission rate in TDMA system. The guard time present in the case of TDMA should be minimum. They already said in FDM system we might have used the guard bands, and we should effectively use the guard band, and it should not be drain out the entire bandwidth. And similarly, the guard time, this is present between one user and other user. The switching of chance between first user and the second user should be as minimum as possible. The main advantage of TDMA is very cost effective, because this actually eliminate the requirement of duplexes in the system. That is actually cost effective compared to FDMA system. TDMA technology is used to separate users with the respect of time, and the interferences will be naturally going down because we are not separating users and teams of frequencies, but the same frequency will be utilized by different users at different particular time. So there is no possibilities of some user to users using the same frequency. So this is all the features we get in TDMA system. Secondly, efficiency in TDMA system. The calculation of efficiency in TDMA system is very important because TDMA uses high overhead than compared to the FDMA. In FDMA system, the overhead that we used that was very minimum. So the efficiency of TDMA system is completely depends on overhead information. So we cannot eliminate the overhead in TDMA system. The efficiency of TDMA system is a measure of what percentage of transmitted data that contains information out of total transmitted data, how many bits represent information and how many bits represent overhead. So that is actually efficiency of TDMA. It can be measured by using an expression which is represented by eta f equal to 1 minus BOH over BT times 100%. Here BOH represents number of overhead bits per frame and BT represents the total number of bits per frame. And in order to calculate BOH, can be calculate the expression BOH is the number BOH equal to NR times BR plus NT times BP plus NT times BG plus NR times BG. NR represent the number of reference burst per frame. BR represent the number of overhead bits per reference burst. NT represents number of traffic bursts per frame. BP represents the number of overhead bits per preamble in each slot. BG represents equivalence bits in each guard time interval. The total number of bits calculated by the expression BT equal to TF times R, where TF represents form duration, R represents channel bit rate. So the total frame efficiency can be calculated by substitute the value of these two equations. Now we will talk about the number of channel in TDMA system. So now the total number of channels that can be operated in TDMA system. So in TDMA system, the total capacity of channel can be determined by multiplying the number of TDMA slots per channel by the number of channels available. So it is given by the expression n equal to m times b TOT minus 2b GER over VC. Only difference between this equation, the total capacity equation, is based on the number of usage available in the system, and by eliminating the m, the equation is as similar to the n equation of FDMA system. The m represents maximum number of TDM users supported in channel. Bleed over is users who are located in start of the bandwidth, and it should not interfere with the other channel. So that was all about the TDMA.